Okay, it's going to be quite difficult to draw, but 2 points are visible from A, but not accessible. Bearings of P and Q from A, so I've got A here, and therefore I need north line, and P is at 15 degrees, so that's P, and Q is at 34 degrees, so I'll put Q here at 34 degrees, so that's what I've got. That is 15, and that is 34 degrees. And we got B, which is 100 meters due east of A, so that's 100 meters. And we've got P is, I need a north line, so we've got a bearing. P is 305 degrees, and Q is all the way around there. Q is 325 degrees, and I've got to calculate PQ, that distance there. So I'm going to need to have a triangle. So what I'm going to do is put a few angles in there, and it's quite important that A or B is due east of A, so this goes at sort of the 90 degree line, so that means I can add some angles. It means that this angle here is, to get to 305, it's 270, that's 35 degrees, and this one here, angle there, is 20 degrees, a bit further on, so the whole angle there is 55 degrees. And what have we got here? That's 34, so that's 56 degrees. Various other bits and pieces. Right, to start off with, in order to work out this, I need to have a triangle, and the only triangle I can get will be the triangle here, or PQB. And because I've got more space in that diagram, that's what I'm going to do, choose PQB. And I'm going to need to know, I've got the angle, I need to know that length and that length. So that's what I'm going to start off with. So I'm going to work out QB to start with. So to do that, I'm going to use triangle QAB. That's 100 meters, and I'm trying to find this length here. If I know that angle, I do know that angle, because I can use angles in a triangle at up to 180. So that angle is 180 minus 56, which is there, and minus, that's 55, 35 and 20. And that is 69 degrees. So now I can do it. I want this length here, so I'm going to get QB, and I need to use a sine rule. And the reason I use a sine rule is because I've got a known pair. I know that one with 69 degrees, and that. So QB over sine of the angle relates to QB, which is 56, equals 100 over sine 69. So QB equals 100 over sine 69 divided by sine 56, and that equals 88.80194. Keeps on going. Okay, so that's worked out QB. And now I want to work out PB. If I work out PB, I'm going to be most of the way through there. So PB, I'm going to use this triangle here. So APB. So I'm going to work out PB. That's what I'm going to find out. Over, and the one which relates to PB, if I highlight it, PB is that length there, and 56 degrees is related to it. So that'll be sine 56. And that one's going to equal, yet again, the 100 over, hang on, it's not sine 56, that's 15 there, so the whole angle I need is that bit there, so that would be 75, so it's not 56, that's 75, and it's 100 over the bit which relates to 100, and it's this triangle we're talking about, so that angle there is 180 minus 75, and then minus the other angle, which is 35, and that equals 70 degrees. So that's 70 here, so that's over sine 70. So PB equals 100 over sine 70 times by sine 75. So PB equals 102.79167. So I now know PB, and I've got QB, and now I've got this triangle. So I should be able to work it out now, because I've got an unknown pair, 20, and I want to find the length up there. So it's going to have to be the cosine rule. So I'm going to have cosine rule, and that means that PQ squared equals QB squared, which is 88.80194 squared, plus PB, which I just worked out, 102.79167 squared, minus 2 times those two lengths times together, 88.8, I'll leave it like that, times 102.79 times by cos of the angle between them, and the angle between them is what I've highlighted there, is 20 degrees. And this says that PQ squared equals 1296.696381. So PQ is the square root of that, which is 36.00967066. And so PQ, which is what they asked for, the length PQ, equals 36.0 centimeters to 3 significant figures. They can't be centimeters, they surely. No, it's not centimeters, it's meters. 36.0 meters, because that's the unit there. And sorry about the mistake there, but that's done.